Are you using Node.js? Do you want to learn to use MongoDB? If so, this is the video series for you. Hey everybody, I am Lauren Schaefer and I am a staff developer advocate at MongoDB. I love helping developers be successful as they build their apps. In this quick start video series, I'll walk you through the basics of how to get started using MongoDB and Node.js together. So today I'll walk you through how to connect to a MongoDB database and then how to execute each of the CRUD operations. If you're not familiar with that acronym CRUD, it stands for Create, Read, Update, and Delete. Now, for those of you who prefer reading over watching videos, I've got you covered. I have an article series that covers the exact same content. So check out the description below for a link. Also, I have a GitHub repo that contains all of the code you'll see me write here today. Again, check that description below for a link. With that, let's jump right in. The first thing we need to do is get set up. I'm going to be working today in VS Code, but feel free to use whatever code editor you like. The first thing I'll do is check that I have Node installed. So I'll run node-v. As you can see, I have version 14.15.4. Next up, I want to install the MongoDB Node.js driver. The Node driver allows you to easily interact with MongoDB databases from within Node.js applications. You'll need the driver in order to connect to your database and execute queries. So if you don't have the MongoDB Node.js driver installed, you can install it with npm install MongoDB. All right, and I can check what version I'm running with npm list MongoDB. As you can see, I'm running the beta version of 4.0. The next thing we need to do is create a MongoDB database. Now, the easiest way to get started with MongoDB is to use MongoDB Atlas. Atlas is MongoDB's fully managed database as a service. I love to use it because I don't like managing databases myself. So this is Atlas, and I've already created a new project. Let's create a cluster. Now, at a high level, a cluster is a set of nodes where copies of your database will be stored. Now, I'm going to choose to create a free cluster because I like free things, but there are a ton of options here you can choose from. It's definitely worth exploring, but I'm just going to skip over it for now and click Create Cluster. Creating a cluster takes a few minutes. I don't feel like waiting, so with the magic of editing, I'm just going to skip ahead. Now that our cluster is created, let's put some data in it. I'm going to choose to load some sample data. This will take a minute or two, so once again, I'm just going to jump ahead. All right, our data is loaded. Let's start working on connecting to our database. So I'm going to click this Connect button. This dialog is going to walk me through how to get connected. Atlas has a built-in security feature. It's super handy. Only certain IP addresses can connect to the cluster. So I'm going to add my IP address. Now I'm going to create a database user. So I'm going to name the user demo. I'm going to input a password. And be sure if you're following along with me, note this username and password. You are going to need it again later. So now I get to choose my connection method. I want to connect from a Node.js script, so I'll select Connect Your Application. I'll select Node.js as my driver, and then I'm going to copy this connection string. Now that my database is set up, it is time to code, right? That's the fun part. So let's write a Node.js script that connects to the Atlas cluster I just created and just lists all the databases in that cluster. I'm going to hop back over to VS Code and I'm going to create a new file. I'm going to name mine demo.js. So first thing I'm going to do at the top of my file is get the Mongo client. So I'll say const Mongo client equals require MongoDB. The Mongo client is what I'm going to use to connect to my MongoDB database. So I'm going to kick things off with a main function. And let's make it asynchronous. Inside of this function, I will connect to the MongoDB cluster, call functions that query the database, and then disconnect from the cluster. So the first thing I'm going to do inside of main is create a constant for my connection URI. I'm going to paste the connection URI that I copied in Atlas a few moments ago. Now I need to make sure I update my username and password to match the database user I created. Now just a note here, the username and password I'm using here are not my Atlas credentials. This is the database user you saw me create in Atlas just a moment ago. Now that we have our URI, we can create an instance of Mongo client. So we'll say const client equals new Mongo client URI. Now I'm going to connect to my cluster. So I'll say await client.connect. Client.connect returns a promise. So I'm using the await keyword to indicate that I should block further execution until that operation has completed. Now client.connect could throw an error, so I'm going to wrap this call in a try catch. And I'm not going to do anything fancy. I'm just going to send that error to console.error. Now I want to be sure to close the connection to my cluster, so I'm going to end the try catch with a finally statement. And we'll put await client.close in there. So once we have our main function written, we need to call it. So we'll say main, and let's send any errors just out to the console. So we'll say .catch console.error. All right, let's save the script and run it. So in my terminal, I will type node demo.js, and nothing happened. That's actually good news. That means that nothing blew up. So let's actually do something with that connection. Let's list the databases in our cluster. So I'm going to create a new function named list databases. And I'm going to set the Mongo client as a parameter. And let's make this an asynchronous function. All right, so to get our list of databases, we'll use client.db.admin.listDatabases. And let's await these results before continuing on. And then let's assign the results to a constant named databases list. Now that we have the list of databases, I'm just going to print them out. So I'll say console.log databases. Then I'm going to print each one. So I'll say databases list.databases.forEach. And we'll let's call the param db, and then let's just log each database name. console.log-db.name. All right, so my function is good. Now I just need to call it. So inside of main, I'm gonna scroll up, I could say await list databases, and I'm gonna pass the Mongo client. All right, let's try this out. Let me save my file, and I'm going to run it again. And hey, there is my list of databases. So we know we're successfully connected. We're pulling data out of our cluster. Pretty straightforward, right? Okay, so before we go any further, let's take a moment to understand how data is stored in MongoDB. MongoDB stores data in BSON documents. BSON is a binary representation of JSON. JSON stands for JavaScript Object Notation. So when you read MongoDB documentation, you'll frequently see the term document, but you can think of a document as simply a JavaScript object. Now, for those of you coming from the relational database world, you can think of a document as being roughly equivalent to a row in a table. Now, MongoDB stores groups of documents in collections. Now, for those of you with relational database backgrounds, you can think of a collection as being roughly equivalent to a table. Now, every document is required to have a field named _ID. The value of _ID must be unique for each document in the collection. The handy thing is, MongoDB will automatically create an index on _ID for you. Now, you can choose to make the value of _ID meaningful rather than a somewhat random object ID if you have a unique value for each document that you'd like to be able to quickly search. So let's take a look at some data. In this video series, I'm going to use the sample Airbnb listings data set. Now, the sample Airbnb database contains one collection called Listings and Reviews. This collection contains documents about Airbnb listings and their reviews. Pretty straightforward title, right? So let's take a look at a document in the Listings and Reviews collection. So here you can see the listing has an ID, a listing URL, a name, a summary, and so much more. You can see a few different types in this document. So we can see the name is a string, the last scraped is a date, and bedrooms is an integer. Now let's look at amenities. Amenities is an array. Now if we expand it, we can see that it's storing an array of strings. All right, let's take a look at address. Address is an object. Here you can see the address object has fields and values, as well as another object inside of it. Let's take a look at one more. Let's look all the way down at the bottom of the document at reviews. We can see reviews is an array, and it's actually an array of objects. So as you can see, you have a lot of flexibility in how you model your data when you use MongoDB. For more information on how MongoDB stores data, check out the MongoDB Back to Basics webinar that I co-hosted with Ken Alger. And as always, I'm going to put a link in the description below. All right, now that we've connected to a database and we know how MongoDB stores data, let's kick off the CRUD operations. And remember, CRUD stands for create, read, update, and delete. So I'm going to return to VS Code, and I'm going to keep working in the same file. So let's start with the C in CRUD, that's create. I'm going to begin by creating a new Airbnb listing. So I'm going to create a new function named create listing. And let's make this an async function. For the params, we need that Mongo client, as well as the new listing we need to create. So to insert the new listing, we will say client.db. Now we want the sample Airbnb database. And inside of that database, we need to access the collection named Listings and Reviews. From that collection, we can call insertOne. We'll pass the new listing to insertOne. InsertOne will insert a single document into the collection. The only required parameter is the new document that will be inserted. If our new document does not contain the underscore ID field, the MongoDB driver will automatically create an ID for the document. Super handy. So that's all we need to pass to insertOne. We want to wait for the results, so I'll add a wait here. Let's assign the results that come back to a constant named result. And finally, let's log the ID of the newly inserted document. So I'll say console.log, new listing created with the following ID, result.insertedID. All right, that's all we have to do for this function. So I'm going to head back up to main. I'm going to get rid of this call to list databases, and instead I'm going to call create listing. And I'm going to pass the connected Mongo client. I'm also going to create an object for the new listing. So I'm just going to set a few fields for this listing. Let's give it a name. How about Lovely Loft? And for the summary, let's say a charming loft in Paris. For bedrooms, I'll set it to 1. For bathrooms, I'll also set it to 1. Let's be sure to await the results of create listing. All right, let me save this and let's run it. And we can see we've created a new listing. Nice. Now note that I did not include a field named underscore ID in the document, so the MongoDB driver automatically created an underscore ID for me. All right, so now we know how to create a single document. Sometimes you'll want to insert more than one document at a time. So you could choose to repeatedly call insertOne over and over. The problem is that depending on how you've structured your code, you may end up waiting for each insert operation to return before beginning the next. And this could result in slow code. Nobody wants that. So instead of calling insertOne, I could call insertMany. insertMany will insert an array of documents into your collection. insertMany has one required parameter, and that is an array of documents that should be inserted. Let's write a function to create multiple Airbnb listings. So I'll say function create multiple listings. And let's make this an asynchronous function. For params, let's pass the client as well as an array of new listings. Now the inside of this function is going to look very similar to what we did in the previous function. So we'll say access the sample Airbnb database and then the listings and reviews collection. And instead of calling insertOne, I'm going to call insertMany. And we'll pass the new listings to insertMany. Let's assign the results to a constant named results. And then let's just log how many listings were inserted, as well as the IDs of the new documents. So I'll say console.log result.insertedCount. That's how many new listings created with the following IDs. And then let's just log those IDs. So I'll say console.log result.insertedIDs. Let's call this function. So going back up to main, let's get rid of this call to create listing. We'll say await create multiple listings, and I'll pass the Mongo client. Now I've prepped a couple of listings to insert, so I'm just going to paste those here so you don't have to watch me type them. Now note, every document does not have the same fields, which is perfectly okay. I'm guessing that those of you who come from the relational database world will find this incredibly uncomfortable, but it really will be okay. When you use MongoDB, you get a lot of flexibility in how to structure your documents. So if you later decide you want to add schema validation rules so you can guarantee your documents have a particular structure, you can. All right, let me save this and I'm going to run it. All right, we can see 3 new listings were created and we have a list of their IDs. It worked. So that takes care of the C in CRUD. Let's move on to R, read. So let's begin by querying for an Airbnb listing in the listings and reviews collection by name. Let's create a function named findOne listing by name. And let's make this an async function. For the params, let's use the Mongo client and the name of the listing that we want to find. All right, let's write our query. So we'll say client.db sample Airbnb .collection listings and reviews .findOne. FindOne will return the first document that matches the given query. Even if more than one document matches the query, only one document will be returned. FindOne has only one required parameter, and that's a query of type object. The query object can contain 0 or more properties that MongoDB will use to find a document in the collection. If you want to query all documents in a collection without narrowing your results in any way, you can simply send an empty object. Since we want to search for an Airbnb listing with a particular name, we're going to include the name field in the query object that we pass to findOne. So we'll set the name of the listing right here. All right, and let's await this result. And let's store the results in a constant named result. Depending on what name is passed, we may or may not get a result. So if we get a result, let's log found a listing in the collection with the name of listing. And then let's log the result. Else, we didn't get a result, so we'll say console.log no listings found with the name of listing. So let's call this function. Heading back up to main, I'm going to delete this call to create multiple listings. Instead, I'm going to say await findOne listing by name. And I'll pass the client and the name infinite views. Now this is one of the documents I created a minute ago when I called create many. So let me save this file, clear the terminal, and run the script. And there it is. We can see our document for infinite views. So now you know how to query for one document. Let's discuss how to query for multiple documents at a time. Let's say we want to search for all Airbnb listings that have a minimum number of bedrooms and bathrooms. So let's create a function. Let's call it find listings with minimum bedrooms, bathrooms, and most recent reviews. Wow, okay, that's a really long function name. We probably could be more concise, but it's fine. Moving on. Let's make this an async function. For params, as always, we're going to take a Mongo client. Now we actually need several other params, so let's use destructuring. So we want to set a minimum number of bedrooms, and we'll set the default to 0. Minimum number of bathrooms, again, we're going to set the default to 0, and maximum number of results, and we'll set that to numbers max save integer. So how are we going to find multiple documents? We can use find. Similar to findOne, the first parameter for find is the query object. You can send 0 to many properties inside the query object. So let's start building our query. So we'll start how we always do. Client.db sample Airbnb .collection listings and reviews .find. We know we want to check that the listings have a minimum number of bedrooms. So we'll say bedrooms is greater than or equal to minimum number of bedrooms. Remember, that's our function argument. And let's do the same thing for bathrooms. We'll say bathrooms is greater than or equal to minimum number of bathrooms. So here I'm using the $GTE, which means greater than or equal to. So I just want you to be aware that MongoDB provides a variety of other comparison query operators that you can use in your queries. So check out the official documentation for more details on those operators. Okay, so this query is going to return a cursor. A cursor allows traversal over the results set of a query. So let's store results of this query as a constant named cursor. You can choose to use cursor's functions to modify what documents are included in the results. For example, let's say we want to sort our results so that those with the most recent reviews are returned first. So I could choose to sort by last review in descending order, which is the -1. So this query would actually match 192 documents in the collection. I don't want to process that many results inside of my script. Instead, I want to limit the results to a smaller number of documents. So at the end of this query, I can chain limit. As the name implies, limit will set the limit for the cursor. Now that I have this cursor, I could choose to iterate over this cursor to get the results one by one. Instead, I'm going to retrieve all of the results in an array. So I'll call cursor's toArray function. The result is a promise, so I'll add a wait here. And then I'm going to store this in a constant named result. I've written some logging code that I'm just going to paste in so you don't have to watch me type it. What it's doing is printing out a summary of each listing. Let's call this function. So heading all the way back up to main, let's get rid of this call. And let's say await find listing with minimum bedrooms, bathrooms, and most recent reviews. And I'll pass the client. And then I'll set the minimum number of bedrooms to 4, the minimum number of bathrooms to 2, and the maximum number of results. Let's do 5. So let me save the file. I'm going to clear the terminal and let's run the script. All right, I'm going to expand the terminal and we can see 5 listings that each have at least 4 bedrooms and 2 bathrooms. Pretty snazzy, right? All right, we are halfway through the CRUD operations. We are doing it. All right, now that we know how to create and read documents, let's discover how to update them. Let's begin by updating a single Airbnb listing in the listings and reviews collection. We can update a single document by calling updateOne. UpdateOne has two required parameters. The first required parameter is the filter, which is used to select the document to update. You can think of the filter as essentially the same as the query param that we used in findOne to search for a particular document. You can include 0 properties in the filter to search for all the documents in the collection, or you can include 1 or more properties in order to narrow your search. Now, the other required param is the update operations to be applied to the document. MongoDB has a variety of update operators you can use, such as increment, set, unset, and a bunch of others. So check out the official documentation for a complete list of the update operators and their descriptions. UpdateOne will update the first document that matches the given query. Even if more than one document matches the query, only one document will be updated. So let's create a function that will update an Airbnb listing with a particular name. So let's name it update listing by name. As usual, we'll make it an async function. And for params, let's use the Mongo client, the name of the listing, and the updated listing. So let's write our query. We'll say client.db sample Airbnb .collection listings and reviews .updateOne. Now remember, we need to pass 2 arguments. So first is the filter. We want to query by name, so we'll filter where name is equal to the name of the listing. For the second argument, we need to pass the update operation. We'll use $set and we'll pass the updated listing. Set will set new values for new or existing fields in the document that we are updating. The document that we pass to set will not replace the existing document. So any fields that are part of the original document, but not part of the document that we pass to set, will remain as they are. Okay, so this looks good. Let's await the results. And let's assign them to a constant named result. All right, last thing we want to do in this function is log the results. Let's log how many documents matched our filter. So we'll say console.log result.matchedCount documents matched the query criteria. And then let's log how many documents were updated. So we'll say console.log result.modifiedCount documents were updated. Okay, let's test this out. So I'm going to head back up to main. I'm going to delete this, and I'm going to call my update function. So I'll say await update listing by name. I'll pass the Mongo client, and I want to update the infinite views property that I keep working with. And I think I'm going to update it so it has 6 bedrooms and 8 beds. Okay, looks good. Let's run it. So let me clear my terminal, and I'm going to run the script. All right, excellent. We can see one document matched the query criteria and one document was updated. Love it. Now let's take a few minutes to talk about upsert. Upsert is one of the options you can choose to pass to updateOne. Upsert is a super handy feature. It allows you to update a document if it exists or insert a document if it does not. For example, let's say you wanted to ensure that an Airbnb listing with a particular name had a certain number of bedrooms and bathrooms. If you did not have upsert, you'd first use findOne to check if the document existed. If the document did exist, you'd use updateOne to update the document. If the document did not exist, you'd use insertOne to create the document. When you use upsert, you can combine all of that functionality into one single command. So let me show you how this works. I'm going to create a function named upsert listing by name. For params, it's going to be the same as our last function, a Mongo client, the name of the listing, and the updated listing. And let's make this function async. This query is going to be very similar to the one I just wrote. So as any great developer does, I'm just going to copy and paste. So I'll copy that query and I'm going to paste it in my new function. The only thing I need to change is that I'm going to pass an optional param. I will set upsert to true. Now let's add some logging. Let's print how many documents matched our filter. So we'll say console.log result.matchedCount documents matched the query criteria. Then let's check if anything was upserted. We'll say if result.upsertedCount is greater than 0, console.log one document was inserted with the ID result.upsertedID. Since we're calling updateOne, we know only one document's going to be inserted. Else, we'll log how many documents were updated. So we'll say console.log result.modifiedCount documents were updated. Looks good. Let's try it out. Back up to main. We'll replace this call with our new one. So let's say if we aren't sure if a listing named Cozy Cottage is in our collection, or if it does exist, it might hold old data. Either way, we want to ensure the listing that exists in our collection has the most up-to-date data. So we'll say await upsert listing by name and pass the client. Now, the name of the listing I want to upsert is Cozy Cottage. For the document I want to upsert, I'm going to set the name to Cozy Cottage. I'm also going to set the number of bedrooms to 2 and the number of bathrooms to 1. So let's save the file. I'm going to clear the terminal and run the script. All right, we can see 0 documents match the query criteria, so 1 document was inserted. Now let's say the owners do renovations, they add on an extra bathroom. So I can use this same function call and just update the bathrooms to 2. So let me do that. And I'll save this and I'm going to run it again. And here we can see 1 document matched the query criteria and 1 document was updated. So upsert can come in pretty handy. Now sometimes you'll want to update more than 1 document at a time. In this case, you can use updateMany. Now, like updateOne, updateMany requires that you pass a filter of type object and an update of type object. You can choose to include options as well, and upsert is one of those options. Let's say that I need to ensure that every document has a field named property type. Let's create a new function called update all listings to have property type. As usual, I'm going to make this an async function. And in this case, I only need 1 param, and that's the Mongo client. Let's write a query to update any listing that does not have a field called property type. So I'll say client.db sample Airbnb.collection listings and reviews updateMany. For our filter, we'll check to see if the property type field exists. So we'll say property type exists is false. So where the field does not exist. Then we need to pass our update operation. So we'll use $set like we did previously, and we'll set property type to unknown. UpdateMany will return a promise, so let's await the results. And then let's assign them to a constant named result. Let's just add some logging. So let's log how many documents match our filter. So we'll say console.log result.matchedCount documents matched the query criteria. And then let's log how many documents were actually updated. So we'll say console.log result.modifiedCount documents was or were updated. So let's try this out. Heading back up to main, we'll say await update all listings to have property type, and we'll pass the Mongo client. So let's save. I'm going to clear my terminal, and let's run the script. Okay, we can see 6 documents did not have the property type field set, and 6 documents were updated. Now, all of the documents in our collection have the property type field set. So if we take a look in the collection, we can see that the Cozy Cottage document I created earlier in this video now has property type set to unknown. Listings that contained a property type before we called updateMany, they remain as they were. For example, the Spectacular Modern Uptown Duplex listing still has property type set to apartment. So those are the basics of updating documents in MongoDB. All right, now that we know how to create, read, and update documents, let's tackle the final CRUD operation, delete. Let's begin by deleting a single Airbnb listing in the Listings and Reviews collection. We can delete a single document by calling deleteOne. deleteOne has one required parameter, a filter of type object. The filter is used to select the document to delete. You can think of the filter as essentially the same as the query param we used in findOne and the filter param we used in updateOne. You can include 0 properties in the filter in order to search for all the documents in the collection, or you can include 1 or more properties and narrow your search. deleteOne will delete the first document that matches the given query. Even if more than 1 document matches the query, only 1 will be deleted. Okay, so let's create a function to delete an Airbnb listing with a particular name. So let's name this function delete listing by name. For params, let's use the Mongo client and the name of the listing we want to delete. And let's make this an async function. All right, let's write our query. We're going to start the same way we always do. And if you're thinking, Lauren, you really should have made the collection a constant so you didn't have to type this every time, I agree. This was a mistake, but we're going to stick with this pattern anyway. So we'll say client.db sample Airbnb.collection listings and reviews .deleteOne. We want to delete the document where the name is equal to the name of listing. deleteOne returns a promise, so I'm going to add await here. And then let's assign the result to a constant named result. Finally, let's log how many documents were deleted. So we'll say console.log result.deletedCount documents was or were deleted. Let's try this out. Let me scroll back up to main and let's call the delete function. So I'll say await delete listing by name. I'm going to pass the Mongo client and let's delete the listing named Cozy Cottage. So I'll save the file. I'm going to clear the terminal and let's run the script. And we can see 1 document was deleted. Now I can actually run this again. And this time we can see that no documents were deleted, which makes sense since I just deleted it. So that covers deleteOne. Sometimes you want to delete more than 1 document at a time. In this case, you can use deleteMany. Like deleteOne, deleteMany requires that you pass a filter of type object. You can choose to include options as well. Let's say we want to create a function that will remove documents that have not been updated recently. So let's say function delete listings scraped before date. That scraped before date, that's the date we're going to use. So let's make this an async function. For params, we're going to use that Mongo client like we always do. And the cutoff date for old documents, that should be deleted. All right, let's write our query. Await client.db sample Airbnb.collection listings and reviews .deleteMany. Now we want to delete documents where last scraped is less than the date that was passed to the function. So deleteMany returns a promise, so we will await the result. And let's assign the result to a constant named result. Last thing we'll do in this function is log how many documents were deleted. So we'll say console.log result.deletedCount documents was or were deleted. By now, you probably know what I'm going to do next. I'm going to head back up to main, and let's get rid of this. Let's delete listings that were scraped before February 15th of 2019. So we'll say await, delete listings scraped before date, client, new date, 2019 to 15. Now for the final time in this video, let's save the file. I'm going to clear the terminal and let's run the script. All right, 606 documents were deleted. That's way easier than manually checking for old documents and deleting them. And with that, we have wrapped up the basics of delete. We covered a lot today, so let's recap. Today I showed you how to connect to a MongoDB database from a Node.js script, and then how to retrieve a list of databases. Next, I shared how MongoDB stores data in documents and collections. Then I showed you the basics of creating, reading, updating, and deleting data. If you want to reference the material I covered today in the future, check out the blog series I wrote that covers exactly what I showed you today. Also, I have a GitHub repo that contains all of the code I showed you today. I will put the links to both of those in the description below. If you want to continue learning, and I hope you do, check out the next video in this series where I will cover the aggregation framework. Now I know the name aggregation framework, it can seem a little intimidating, but it is super powerful and it can be game-changing when you start working with MongoDB. You are not going to want to miss this video. That video is going to be releasing soon, and I will drop a link to it in the description below when it is live. All right, that is all I have for you today. Thanks so much for watching. I hope you enjoy using MongoDB.